All right, I just want to point out that there are now multiple ways that we can solve problems like this. In our last section, I'm going to kind of jump through a little bit because this isn't in the same spot as our triangle proportionality we started with. In the last section, we would split these triangles up and then use those parallel lines to kind of get angle, angle, and then set up my proportions there. So small side, big side, big side. But another proportion will work out for us too, since I can kind of take it from this. So this would be an equivalent proportion. And I just want to point out that you can't use this 8 at the beginning. So we can do x and 20, 32 and 28. So just pointing out that we really need those opposite sides if we want to use the proportionality theorem from this section. But any of these two proportions will work out to solve. So I'm going to solve this one on the left here for us. You guys can try it out and make sure our answers match. So 20 times 32. And I'm thinking we could at least divide the 20 and the 28 by 4. This will be 7. This would be a 5. And I think that's where we're stuck. So 5 times 32 is 160 over 7. So just careful with the proportions you set up. I'll do the same thing over here. I really like to redraw these as separate triangles. We've got a right triangle, 10 and 6. Another right triangle. This one, maybe I'll change my color, would be this big right triangle. So this would be 20 and x. And again, we have this top angle that they shared. So this was our angle, angle. So I can do lots of proportions we can set up now. I'm going to do 10 over 20 equals 6 over x. So remember, you can always simplify first. That might be nice. 1 over 2 equals 6 over x. Really nice because then I can cross multiply and we get x equals 12.